Hi everybody, I'm Pepe. Today I would like to tell you a little story about how I solved a bug in a couple of hours instead of a couple of weeks. So I work on Qt, the framework. As you may know, Qt is a C++ framework, but today's story does not start from C++, it actually starts from JavaScript. How many of... Right, so how many of you know about JavaScript? So, no one, great, okay. So, in JavaScript, what happens if you try to print that? That's nothing surprising, it's a string comparison and output the result. And yes, those two strings are not the same string, that's false. And if you're really good at JavaScript, you may notice that's a double equal operator. JavaScript has also a triple equal operator, but that's still false, don't worry about that. So, yeah, so everything is fine. What does this story has to do with Qt? Well, in Qt there is a JavaScript engine. Actually, there are several JavaScript engines. There is V8 used by Chromium and Blink. There is JavaScript Core used by WebKit. There is V4 used by QML. It's called V4 because it runs half as fast as V8. That joke always works. Yeah, maybe others. So today's talk is about that engine, V4. So in V4, if you try to print that string comparison, that prints true. Whoa, yeah, here we go. So somebody said, yeah, can you please fix this? Because of course it's embarrassing. And I said, I know nothing about JavaScript, not to mention JavaScript engines, so I have no idea where to tackle this. So the first thing I did was I got back into C++. The JavaScript engine in Qt has a C++ API that you can use to script your application. So I built a test case, which does, just builds an object, sets that property 100 on it, and then prints it, and it works. But if you set a property which has that weird name, then this prints on the bottom slide an entirely different thing. So there is clearly something wrong there. So, okay, here we go. I open GDB and start debugging the JavaScript engine in Qt. Well, that's not exactly a trivial task. I don't know if you ever tried to debug a JavaScript engine, but a JavaScript engine is anything but a trivial code base. In particular, a JavaScript engine, a modern JavaScript engine, will use all sorts of trickeries to optimize its performance. Every time a standard says, yes, this is undefined behavior, but in practice it works. Let's use it, why not? Let's tag all the pointers, because when you allocate a pointer, pointers have extra bits of unused space. Let's put information in there. And so GDB crashes on my face a couple of times that couldn't go anywhere. Great. So I was totally lost. I had no idea how to do. I said, okay, I need to learn about this engine. This is going to take me forever. But then I had an idea, a terrible idea. So I thought this, I got a working test case, I got a broken test case. Could it be possible for me to somehow trace down the execution of both test cases and figure out where the execution diverges? Because you know what, eventually the test cases should be deterministic, more or less. So could it be possible to find out? And turns out there is a way. There is a way that has nothing to do with debugging, there's a way that has to do with profiling. How many of you know about the -pg option to GCC or Clang? Yeah, some of you do. So the PG option tells GCC to basically instrument all your function calls in a way that every time you enter a function or you're exiting a function, you can take track of that. This is usually used by a profiler to figure out how long you're inside a function. I do not need that. I just want to know which functions I was walking through and what was the arguments passed to this function, what were the return values. And there is a tool that does exactly that for me. The tool is called UFTrace. It's an awesome tool. There is a poster about this downstairs. So go see that. So UFTrace is a small tool that does exactly that. It uses the information set in place by PG and extracts it. So this is an example of an application that calls, main calls A, A calls B calls C, and UFTrace is able to print that. Great, I can use this. I can apply UFTrace to both test cases and do a diff. Why not? Well, a diff is kind of complicated, I don't want to get there. So UFTrace is actually able to dump a Chromium flame graph of the function calls. So I was able to do some sort of visual comparison. That was easy for me. So I did exactly that. I dumped everything into Chromium. I opened it up. On the top, you can see a working test case. On the bottom, you can see the broken test case. And just play a little bit with zoom and pan until I could identify that region on the right where the function calls are totally different. And I could just zoom in and identify the line of code where there was a divergence. It was that line over there. In one case, diff was taken. In the other case, the if was not taken. And that's pretty much it. Ultimately, it was an overflow detection that didn't work. I fixed the overflow detection, and I fixed it back in 2 hours instead of 2 weeks. Thank you very much.